the second derivative, kind of interesting because this is the concavity finder, right, for the curve, and it has a symbol that looks like this, right? D squared y dx squared. And so we have to come up with this calculation based on the things that we can do, okay? Now, we know how to calculate dy dx. That was the last slide. We can take, and remember, let's go back and take a look. Dy dx was a function of t, so it's not a function of x. So it's not as simple as, okay, just take the derivative of this with respect to x. Well, you can't because it's a function of t. So what you can do here is take the derivative of that with respect to t, okay? That you can do. Now, what would that give us? Okay, that would give us d squared y, which is what we want in the top. But now in the denominator you have dt dx, dt times dx, which is not what we want. We want dx times dx, right? Dx squared. Okay, so there's a calculation we can do to get us d squared y dx squared. Okay, you want to cancel this dt and you want to get another dx in the bottom. So you would get that by multiplying this by dt over dx, or written another way, okay, you would do d squared y, okay, over dt dx, that's what you had, all right, divided by dx dt, which you can calculate, okay. That will give you the calculation you're looking for, okay. So I know I've got a whole bunch of jazz here that is kind of ugly to look at, so let me just recap what you would do to find the second derivative. Okay, you're going to take the derivative with respect to t of the first derivative, and then you're going to divide by dx dt. Now, if you forget all that, you just got to kind of play with the calculations to see what you're after. Okay, this is what you're after: d squared y dx squared. Okay, so let's try it with this example. We saw on the last slide here that dy dx could be written as negative cotangent t. Okay. So what do I need to do to calculate the second derivative? I need to take the derivative of that with respect to t, so d dt of negative cotan t divided by dx dt, right? And what was dx dt? It was negative sine t. Okay, what is the derivative of negative cotangent t? Let me think here. It's negative, well, the derivative of cotangent t is negative cosecant squared t. So the negatives cancel, and I'm going to get cosecant squared t, and divide that by a negative sine t, which is fine. It won't be the multiple choice answer because this is going to be really what? This is another cosecant that could be written at the top, so you could say negative cosecant cubed t. Okay, so this is the concavity finder for your curve. You can analyze the t values for which your curve is concave up or down based on the second derivative. Okay, but this is your formula that's going to get you that. If you forget it, just play around with the symbols until you get to d squared y dx squared.